Kidoki, we're back. This is bubble sorting. This is like where we start with understanding sorting algorithms and stuff like that. So let me jump right into it. Lesson 2, bubble sorting algorithms. So we'll be analyzing the sorting algorithms backed by mathematical formula, which is the basis of most sorting algorithms because we are dealing with what we call standard functions, which are primarily understanding the time complexities of the algorithms that we're running. So the different kinds of standard functions we have are linear, which is the number of inputs multiply by two, like exponentially, kind of. And then we have quadratic, which is multiplied by three. N log n is a cheat code that I found out is like whenever time complexity has a log function, it's understanding that we are primarily dealing with a recursive function because what recursion does is like it splits values. Oh, now we have sorting algorithms that continually call themselves and like they do like partitioning and stuff like that. But that's pretty cool. So I say here one thing that I understand from this is that we need proof as to why we state the program is sorting at the speed regardless of the machine it's running on, determining the time complexity. And this is also known as benchmarking. We are benchmarking, like we are standardizing the function of the algorithm. So I'm going into my notes, like working with bubble sort algorithm. We have an array named A, and we fold the elements. They are five elements in the no, it's an array of six elements, and the max array value would be five. One, two, three. No, I'm tripping. Oh yeah, 0 to 5. Cool stuff. So this means that we do the operation by comparing the values within the array. So we just go index by index comparing the values, right? Which is kind of slow. Thus leading me to this side of my slides here, bro. So I'm like, with any sorting algorithm, I have it sure to have a set of procedures defined according to the functionality of the algorithm itself. Since understanding an algorithm is about understanding the precise steps it needs to follow in order to reach the desired result. I forgot to put that there. So just the standard bubble sort method would look something like this, because all bubble sort does is compare the values within the indexes. So we'll check whether if the value in index 0 is greater than value of index 1. In this case, it's true. So we would swap those values, right? And this is how we would denote the next position or the next index. It's A, this would be A, I, this I here, so 0, and then I plus 1 is taken to 0 plus 1, so 7 by 2, and comparing whether this value is greater than that value. Right. So like we have completed one scan over the input when we can compare the values within an array. The time complexity occurs when we can determine the amount of passes that the sorting algorithm has taken and also determining the number of comparisons that have occurred during that process. We can deduce that the bubble sort average time is order of n squared since we have to sort the array according to the number of elements with the collection of data. N1 is equivalent to denoting n minus n. So we are trying to compare until the comparison of the input value matches that input value. So it's like, let me say 10 minus 10. It would be n minus n, 10 minus 10. So we just denote that as n minus 1 because it's going to be 1, 2, 3, 4, 5, so on and so on and so on. Right, great stuff. After looking at the passes, I didn't make these notes nice here, but now we move into how to get our bubble sort functioning the proper way, which is by setting a flag. Because the main reason that like bubble sort has a bad time complexity, which is like linear, the more inputs you have, the double time it would take to sort those out inputs, right? So like we set up a flag so that with every single pass that happens, right? Let's say we were working with an array of five elements and it only needs to sort once. That flag would say, okay, we sort once and then we exit the function, because if we didn't do that, it would call itself four more times, even though we've already sorted the array or whatever data you're using and stuff. Yeah, this is just a bare bones, just like understanding is this value in the array greater than the next value. If so, swap, and you will do this over and over and over And then yeah, the second kind of bubble sort we do is decreasing the comparisons. So we decrease the comparisons here by saying this should be minus I. So we iterate through the array by its length, right? That's the first step. It's iterating because whenever you're working with like data structures, right, you have to go through each of the elements, and then the second for loop sets this condition here. J should be less than array length minus I.
Listen
So
to
the
rare
more
covers
I
of your
increases,
favorite
the
artists.
more this
I'm
comparison
the YouTube
decreases,
music guy.
right? And then we check whether the value in the previous position is greater than the value in the next position. If so, swap. And then this is how we set up the flag. And yeah, that's it for bubble sort. I'm gonna go into the next one. Let's go.